Welcome to The Explainer. Today, we're tackling the most complex, mysterious machine in the known universe, and it's literally sitting right behind your eyes. Yup, your brain. It's this 3-pound organ that's responsible for absolutely every facet of your personality. Everything you think, everything you feel, it all comes from there. But what exactly is going on in there behind the scenes? Well, let's find out.
So I want you to consider a pretty fundamental question before we get too far in. Who, or maybe what, is really in control? Think about it. When you decided to click on this explainer, or when you choose what to eat for dinner tonight, or decide to stay up late watching just one more episode, are you truly the sole author of those everyday decisions? Or is something else grabbing the steering wheel? We all love to think we're completely in control, but the reality, it's a whole lot more complicated than that.
To really understand why, you have to grasp the sheer scale of the machinery inside your head. You have almost 90 billion neurons working entirely in the dark inside your skull. I mean, just think about that number. They are firing, communicating, and making these microscopic calculations every single millisecond. And the kicker? You have absolutely no conscious awareness of the vast majority of this activity. It's all happening right under your nose, or, well, above it.
Okay, let's dive into this because this quote from neuroscientist Bobby Castori drops an absolute bombshell. That unified sense of self, that very clear feeling of you sitting right there behind your eyes calling the shots and making choices, it's actually a biological construct. It's a beautifully crafted illusion generated by those 90 billion neurons working together.
Now, most of the time, your brain operates like a well-oiled, highly coordinated machine. But we actually gain our absolute deepest insights into how it works by looking at the glitches. Like what happens when different parts of this massive system fall out of sync. A perfect example of this is sleepwalking. People can walk, eat a whole meal, or even drive a car while completely asleep. Seriously, how is that even possible? Well, the answer lies right here in the prefrontal cortex. You can think of this as your brain's decision-making and self-awareness center. It's the boss. In a sleepwalker, the motor cortex that controls physical movement and the visual cortex that processes sight are completely awake and functioning perfectly. But this crucial prefrontal cortex, it stays deeply asleep. So your body is out there performing incredibly complex, unscripted actions entirely unconsciously.
Another really fascinating window into our lack of control is anesthesia. When a patient goes under for surgery, their highly dynamic, varied brainwaves suddenly drop into this dull, slow hum. Why does that happen? Because the anesthesia drugs specifically target communication hubs, like the thalamus. By shutting down this central way station, different parts of the brain can't talk to each other anymore. And when they stop talking, consciousness simply vanishes. Poof!
So it's pretty clear that communication between brain regions is absolutely essential for our sense of a unified self. But what if we took that idea to the extreme? Like, what if an entire half of your brain physically could not talk to the other half? It sounds like science fiction, right?
But this actually happens. In patients who undergo a rare medical procedure to treat severe epilepsy, known as split brain surgery, surgeons sever a structure called the corpus callosum. Think of it as this massive neural highway of fibers connecting the left and right hemispheres of your brain. When this bridge gets cut, a seizure literally can't spread from one side to the other. But it also creates a stunning side effect. You end up with two completely isolated systems operating independently inside a single head.
And it creates this staggering division of labor. Your left hemisphere controls your language, your speech, and the right side of your body. Meanwhile, your right hemisphere handles emotions, visual space, and the left side of your body. When they're severed, these two halves no longer share any information. They literally become two completely separate minds sharing one skull. It's wild.
And this famous experiment with a split-brain patient named Joe brilliantly illustrates just how real this division is. Researchers flashed the word Texas to his visual field in a way that only his right nonverbal hemisphere saw it. When they asked Joe what he saw, he said nothing. And he wasn't lying. His talking, left brain truly didn't see a thing. But when they asked him to draw with his left hand, which, remember, is controlled by that right brain, he seamlessly drew a cowboy hat. One mind managed a complex act without the other even knowing it happened.
Split brain patients show us just how compartmentalized the mind really is under the hood. But hey, even with a perfectly intact, fully connected brain, there are invisible forces pulling our strings every single day. Deep emotional drives and external factors dictate our choices far, far outside of our conscious awareness. Take the trust game, for example.
It's an economics experiment where people have to choose to be greedy or generous with money. Researchers found that the brain basically acts like a climate control system during this. The insula acts as the thermometer, constantly reading our gut feelings and sending signals of social guilt. Meanwhile, the prefrontal cortex steps in as the thermostat, regulating our behavior. It has to constantly balance our selfish, primal desires for a reward against our social desire not to harm other people.
And we know exactly how vital this emotional thermostat is because of tragic cases like Phineas Gage. Gage was this 19th century railroad worker who had an iron rod blown straight through his prefrontal cortex in a horrible accident. Miraculously, he survived, but he lost his brain's thermostat. His core intelligence was totally intact, but his emotional regulator was just gone. It fundamentally altered his personality, completely removed his social filter, and made him incredibly impulsive.
But check this out. These hidden influences go even deeper, literally into our very DNA. Consider neuroscientist Bianca Jones-Marlin's groundbreaking work on epigenetics. She paired the smell of almonds with a mild shock in mice. To cope, the mice grew extra cells in their noses just to detect almonds better. Amazingly, when those mice had babies, their offspring were born already having those same extra almond-detecting cells. The trauma literally physically altered the biology of future generations. So, the absolutely crucial point here is that we don't operate in a vacuum. We have a multitude of hidden puppet masters shaping our daily behaviors. Our gut feelings, the heavy weight of social expectations from everybody around us, the ancestral trauma locked right there in our biology, and basic survival regulations, they all drive our decisions way before our conscious mind even gets a chance to weigh in.
Which brings us to what I like to call the turn. If all these different things are influencing us behind the scenes, how do I even know when I have actually made a decision? What is that feeling of control, and honestly, can we even trust it? To answer this, scientists devised a truly mind-bending clinical experiment targeting our very sense of agency. Using a transcranial magnetic stimulation, or TMS device, scientists monitored a patient's brain to pinpoint the exact, precise millisecond they intended to move their finger. Then, just 50 milliseconds before the patient actually moved it, the scientists triggered a magnet to force the movement instead. Because the external magnet interfered right at the exact moment of intent, the patient reported feeling absolutely no agency over the movement, even though they were the ones who originally initiated it in their own brain. This reveals something staggering. Our feeling of agency, that concrete, unshakable belief that we are the ones in charge, is actually incredibly fragile. As neuroscientist Anil Seth explains, the brain basically just looks at what the body did retrospectively and then writes a story to figure out if it makes sense as an act of free will. It's an after-the-fact narrative. Our brain is just telling us a story to make sense of the world.
Okay, at this point, you might be feeling a bit uneasy. I get it, but let's flip the script for a second. Is letting go of conscious control really a bad thing? What if the secret to our highest achievements isn't gripping the steering wheel tighter, but learning to completely let go? What if surrendering agency actually unlocks our peak potential?
To explore this, neuroscientist Charles Limb did something amazing. He put professional freestyle rappers inside an MRI scanner. He scanned their brains while they performed a set of strictly memorized lyrics, and then he scanned them again while they completely improvised, just making up complex rhymes right there on the spot. Now, what's really interesting about this slide is the sheer, stunning contrast in the data. When they were just reciting memorized lyrics, the prefrontal cortex, our conscious control and self-monitoring center, was highly active. But during that spontaneous, rapid-fire freestyle improvisation, that control center actually deactivated. The brain literally turned down the conscious dial to let the creativity flow.
As Charles Limb points out, if you try to over-control some things, your performance is going to crash. Think of a professional basketball player. They can stick a free throw effortlessly, totally on autopilot. But if you walk up and tell them they win $1 million if they make the next shot, they inject conscious control into a highly practiced, unconscious skill. They start to overthink it, and boom, they choke. So, take a deep breath. Yes, your brain is a massively complicated collection of intricate parts. And yeah, you have absolutely no awareness of most of them. But that is okay. All of these hidden processes, your ancestors' biology, your emotional thermostats, your spontaneous bursts of creativity, they all combine to make up your entirely unique identity. The unconscious you is still you.
By understanding these incredible hidden mechanisms, we can finally stop over-controlling the things we shouldn't and start paying real attention to the forces actually driving our lives. So, I'm going to leave you with this final thought. If you aren't the sole author of your choices, but rather this amazing collaboration of billions of neurons, past histories, and social connections, how will you write your next chapter? Thanks so much for joining me on this explainer, and remember, keep your mind wide open.